Okay, so if we want to sketch the graph of this parametric relationship, we can use a data table where we make up our own values for t. Like if we plug in t equals 0, we get x is 4, and we get y is 0. We can't plug in a negative value for t, right? Because we get a square root of a negative. So let's plug in t equals 1. So we get x is going to be 3 when you simplify, y is 1. I don't want to plug in 2 because I'll have a square root of 2. Let's plug in 4 for the next one. Simplify in both those equations. Let's plug in t equals 9. I'm thinking of just integers, so we get 1 and we get 3. And I know it might seem crazy, but look, these aren't that bad of data points to graph, right? T might be getting bigger, but it's okay because we're only graphing these points on an x and y grid. So let's do 25. I'm going to skip over one of them. And I did that because I know that eventually this is going to turn negative with this pattern. So you're going to get negative 1, and over here you're going to get 5. And if I plug in 36 for t, I'm going to get negative 2, because 4 minus 6 makes negative 2. And then over here I'm going to get 6. So enough data points. 4 in the x, 1 in the y, put a dot. 0 in the y, put a dot. 3 in the x, 1 in the y, put a dot. 2 in the x, 2 in the y, put a dot. 1 in the x, 3 in the y, put a dot. Negative 1 in the x, 5 on the y. So they're making a nice straight line. Wait, this says, I forgot this part. 0 is greater than or equal to t. So this is what the book says. In other words, t is less than or equal to 0. Oh, I have that backwards. Sorry. They said 0 is less than or equal to t. Wait, is that what I said before? T is greater than or equal to 0. Okay, but that's all we did. We already obeyed that. So this has an initial point. It starts at t equals 0. And the initial point we already found is 4, 0. Terminal point, though, it has no upper bound. It keeps going. T is greater than or equal to 0, so we never stop. Okay, so this is the initial point, and it never stops going this way. Okay, so we're supposed to find a Cartesian equation, and if you've seen the other videos, this is where you want to solve for one of the variables and plug it into the other equation. So it's easiest to solve for to solve for t here in this equation. Square both sides. So you get y squared equals t. But we'll want to remember, t was only going to be positive over here. You couldn't get a negative out of this result. So y is always positive. Okay. So if I plug in y squared in for t in this equation, then I get x is 4 minus the square root of y squared. Or in other words, x is 4 minus y. But that has to be only when x is less than or equal to 0, okay? Look, this is the Cartesian equation that represents this parameterized curve, but only when x is less than 0, okay? Because you lose some information right here. Y is always being squared, which always makes it positive. And then you take the square root. So this equation does match this parameterized equation, but the book's trying to emphasize it only works when x is, less than or equal to 4 right here. The line, if you were to graph just this line, you get the same graph except it keeps going into the negatives, which isn't the same as this parameterized equation.